In this video, we're going to go over how to square radicals or how to square square roots. It's probably one of the most important ideas in terms of checking your answers involving square roots, and it's one of those things that's not often taught directly, at least not in my experience. So I'm going to teach it directly. Let's check it out. It'll help you a lot, I promise. So what happens when you have the square root of something squared? Right? Well, the square root of a squared, and by the way, our instructions are to simplify. If you think about it, you're saying when you take a square root, you're asking the question, what number when squared, or what number when multiplied by itself, gives me a squared? So you're saying, what number when squared gives me a squared? A. Right? That's like saying, what color is that orange cat? Orange, right? The description's in the actual sentence if you're listening, right? So we're having a be greater than or equal to 0 here. That's a very important piece. We're assuming that these numbers are greater than 0 for now. In a later video, if you're taking this as Algebra 2 or higher, then we're going to involve some absolute values. Okay, so again, we'll use this idea. What number when squared, that's the square root sign, gives me 5 squared? So what number when squared gives me 5 squared? 5. 5 squared gives me 5 squared. So in general, if I take the square root of anything squared, I get that anything back. And the reverse is also true. So had I taken it as like the square root of x, all of that squared. Now you're saying, what number when squared gives me x, and I'm squaring that number. So the squared undoes the square root. They're inverses of each other, so you get x. Another way of looking at that is that you get the square root of x times the square root of x. We know that the square root of x times the square root of x is the same as the square root of x squared, multiplying it by itself twice. And that is equal to the square root of x squared. Again, assume x is greater than or equal to 0. And that is x, because what number when squared gives me x squared? X. So whether the squared's on the outside or on the inside, the square root and raising some in the second power completely undo each other, which is also supported by the fact that you would divide 2 by 2 and get 1. Okay, so again, assuming that that variable is greater than or equal to 0. So more along these lines, this allows us now to take great shortcuts, huge shortcuts. If you have the square root of 73 squared, instead of multiplying it out and then showing it's 73 squared and taking the square root, you can immediately go to the fact and say, well, the squared is undoing the square root and you get 73. That's what this shows right here. That if I take the square root of x squared, I get that x out. We can use that idea here. Now 5 root 3 squared. Well, now be a little careful here. You have a number on the outside. So that's going to be 5 root 3 times 5 root 3. Well, 5 times 5 is 25. You have square root of 3 squared there. Or the square root of 3 times the square root of 3, which is equal to 3. That comes from the product of these two pieces right here and here. And then 3 times 25 is 75. Oh yeah, it's beautiful. Last but not least, if I take the square root of 187 and I square it, again, that undoes the square root, and that leaves me with 187. So it's a very simple yet beautiful property. If you're taking the square root of any non-negative number, so any number 0 or higher, and then you square it, the square and the square root undo each other. They're inverses. It saves you time rather than having to expand it out every single time and show this. It's not a trick. It's a little bit of math, and it goes a long way, especially when dealing with things like, oh, the Pythagorean theorem. Wonder if you'll see that a little later. I think so. See you soon.